Now, we have seen that protons and neutrons are packed tightly in the nucleus, right? In the tight packing, the repulsion of proton breaks nucleus apart, but neutron acts like glue to keep everyone together in the nucleus. Okay, and there's certain ratio between neutron and proton. Too much of a good thing is not good, right? Too much neutron, not good. Too much proton, not good either. They dissociate. Only appropriate number of neutron and proton ratio, that makes the nucleus stable. So the appropriate neutron and proton ratio determine the stability of a nucleus. Does it make sense? Okay, and the nuclear scientists quantitatively measure this stability by using the nuclear binding energy. I'll take a look. Okay, so we call it nuclear binding energy, or NBE. All right, by the definition, the nuclear binding energy is the energy required to break up the nucleus. So the smallest energy required to break up the nucleus into component neutron and proton. I'll take a look here. So let's say we have a nucleus, proton, neutrons in there. The smallest amount of energy that apply and break up all these to individual particles, that is the nuclear binding energy. And we can look at this on the other way around. Now let's take a look. So right now we define the nuclear binding energy as the smallest energy to break up the nucleus, basically. Okay. If you look at the other way, the nuclear binding energy is the energy released when all components of proton and neutron come together, form a nucleus. Okay. Same energy but opposite side. This one absorb, this one release. Could be either way. You can look at from both direction, both perspective. Okay. Now, the nucleus that has too low or too high neutron per proton ratio, they don't have appropriate neutron per proton ratio. So they have small nuclear binding energy, not a lot, not stable, not a lot of energy is needed to break up this nucleus. But those who have appropriate neutron per proton ratio, they're relatively more stable. So this guy will need more nuclear energy to break up this nucleus, or more. So they have higher nuclear binding energy. All right. Now the question is, how much is the nuclear binding energy? Let's take a look on the next video. Now let's talk about it.